And this is Coding with Gautam. And guys, today we are going to be starting the series of Emotion AI. So, what are we doing on Emotion AI? So, today is just the introductory phase. So, what do we do? For Emotion AI, we have to make sure that we are basically creating an AI that when given a dataset, the dataset is basically a grayscale image of a person and the key facial points like the nose, the eyes, the eyebrows, and the mouth. So we can determine their emotion. So let's go to let's go down. This is what our end result wants to look like. Yeah. So basically, we're trying to get like surprise, 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 happiness, happiness, surprise, happiness, happiness, surprise, happiness, sad, anger, surprise, happiness. We're just trying to make sure that an AI can be able to predict. Look, happiness, happiness, surprise, surprise, anger, anger, sad, sad, happiness. It is fairly accurate. So this is the goal. We're trying to create a AI model using TensorFlow, Keras, and other modules to make sure that we can identify what emotions a person is feeling. So let's start. So what are the packages necessary? You're gonna need pandas, you're gonna need NumPy, you're gonna need OS, CV2, Pill, Seaborn, Pickle, TensorFlow, Keras, some specific packages from TensorFlow, Keras, Matplotlib, sklearn, test for test chain split, and TQDM. And we might not use TQDM. So first, we read in the data. The data is put in the description below. You can take it if you want to follow. So df equals pd.read csv data csv. So df.head. So this is the data. The coordinate, like the x and y coordinate of a left eye center, right eye center, left right inner corner, left y outer corner, and then the image is just a bunch of grayscale. And then info, we have all of them are floats except the image is an object. There's nothing empty in the data is all good. The data image is basically just coordinates relative to the image. Then you take the image and then you convert the string representation of the pixel values into NumPy arrays. So these are strings right now. Then you turn it into arrays, and this is like grayscale. So 0 is white, and like zero is white, and as you progress, it becomes darker. So then you reshape this long line of string into a 96 format. Then you apply the colors, and after you do the 96 format, you have this, and you can clearly see the pixels here. So this would be like a smaller number, this would be a larger number. So instead of just having lots of strings, so this originally was this. Wait. Yeah, this string of integers turns into this, because what we have is a grayscale, and then we reshape it into 96 format, and then you basically, on a scale of white to gray, you apply the number and then cmap gray. And so plot random image from the datasets along with key points. Image data is obtained from df image and plot using plt.im show. That's why we need matplotlib. 15 xy coordinates which corresponding to the image, which are these. Since x coordinates are in even columns and y coordinates are odd columns, we can basically just do a for loop in like skipping over each one, and then you plot. Then you just nest it. Then what am I saying? Then you get the random randit, so basically which random number you're talking about, and then you locate the random numbers. For example, if you want to do image 2135, you go to 2135, and then you get all the even and odd columns, then you locate that, and then you graph it. Then figure more faces. Then do the same thing, just like for loop again, and just do create 4x4. These are all the faces we're doing here. Then we make sure the columns are or copied, and then we flip the image along the y-axis just to create an altered data set. So we flip the image, so from that to that, fairly simple. And how do we do that? We basically go to the image nx and just use lambda and then np numpy flip x-axis on 1, and then you take the original image, then you take the flipped image. Then you create a new data frame called alterdf, and next then we increase the brightness. So to create more noise and variation, we're randomly going to increase the brightness of some images so our model can be trained really well. So it clipped the value between white and black. White is 0 and black is 255. So you import random, df2 is copy df, and next thing you use the alter df for not using the original one. Then after you take the alter df, you use the random uniform functions of a numpy clip multiplied by the random number x and make sure it's between 20 and 255. Then you alter the df by you alter the df, you concatenate the altered df and the new df and then the altered df shape. You can see now we have 6240 images and then show image with increased brightness. So that's what we're all doing for today. We're just altering the data and making sure that the data is good for the model to get fed and the model to be created. So let's just recap what we did. We imported all the necessary models. We read the CSV, we loaded in the CSV, we understood the data, making sure that these are just XY coordinates of specific points on the face that the AI will use, and the image grayscale 0 to 255. And then we just go to info, make sure all of them are numbers except the image, that's a string, and then make sure nothing's null. So we turned this large string, we use lambda, next then we create the int pixel, then we split it into 9696, and next we create a square, make sure it worked into a 9696. Then we plot a random one, and the logic on this is that so let's just go back. So we could see that column 0, 2, and 4 are the x coordinates, 1, 3, 5 are the y coordinates. Using that logic, we just do the for loop, make sure we skip every 2, then you plot the x's and y's right here using the x, rx. Then do the same thing for more figures, just making sure all our images, this is what we're going to be dealing with. Then make sure all the columns are copied, create a new alter df, and in the alter df you flip the images to create variation. Then you increase the brightness randomly to also increase variation. So basically we're trying to make sure that our model can identify whether it's bright or dark or flipped, and that it's just not reliant on a specific streamlined type of image. Then just getting the images, obtaining the values, and test chain split will do all that tomorrow. So this is it, getting the data ready. Thank you guys for watching. Don't forget to share, like, and subscribe. This is Going with Gautam, and keep following if you want to make your own AI model that can identify images in the near future. So thank you, Gautam signing out.